What we've got here is a mechanical system that consists of these 3 discs connected by 2 torsional springs. 3 different encoders measure the position of each of these discs. For this system, there's a servo motor at the base here driving the bottom disc, which you can't quite see. I'm just tapping it there. And then that gets transferred through a torsional spring to this second disc and another torsional spring to the third disc. So we're putting in all the energy through a motor at the base of this system here, and we're going to see how that energy gets transferred through this mechanical structure. So what I want to do now is drive this whole structure with a sine sweep. And that way we're going to see the frequency response of the structure as I put in initially a low frequency and gradually increasing to higher and higher frequencies. Putting in a frequency sweep of constant amplitude, and what we'll see is kind of a sharp 0 in the response of the second disc, where almost no energy gets transmitted at that frequency, and then later on actually a resonance where the energy gets amplified at that frequency. So now you can see the low frequency response coming through. And as we go higher and higher in frequency, we hit a 0 on that disc right about now. And now as we go to even higher frequencies, we see quite a strong resonance on that disc. You see now we're getting a lot of energy transferred to disc number 2. And then at even higher frequencies, we're just above the bandwidth of the system, and a small response occurs. So what we see in this plot now is the results of the little experiment we just ran. And the red trace here is the commanded input, which as you can see is just a constant amplitude but getting gradually higher in frequency. And this green plot here is the response of that disc 2. So now you can see at this frequency is where we had that very clear 0 in the response, and then later this resonant peak is from the pole in the response. And at high frequency here we're just above the bandwidth of the system. So here you can see how the frequency gradually starts out at a low frequency and gets faster. And by putting in a variety of different frequencies like this and measuring the frequency response of the system, we can figure out a model for this mechanical structure, and from that design a controller for it. Okay, so what we're going to do now is implement a controller, and the controller drives the motor at the base here, which is on this first disc, and the energy will go up through the spring to this second disc here, and then further up to the top disc. And let me show you on this second one right now where we're at open loop, so I can move it easily. But if I implement the controller, this disc is trying to maintain its position, and I'm going to actually try and command a step change in the third disc here. So my goal is to make the third disc follow a square wave, but my command enters at the base and goes through this whole mechanical structure. Okay, so this is a closed loop step running now. As you can see, we actually get a pretty good response. We had a minimal amount of overshoot and oscillation, even though this is a very lightly damped structure. And actually we'll see on the plot on the computer screen how well it did in following that commanded trajectory. So now you can see the actual response, the red line commanded, and the green line the response of the third actuator, and as you can see it does a pretty good job of following that command.